Hi there. Thought we'd get started with lesson 2. This is from unit 4. We're working through the linear systems. And so today we're going to look at solving these systems algebraically. I love this comment here at the bottom. It says when you try to solve a system by graphing, sometimes it's difficult to actually see the points exactly. When this happens, you can use other methods. And if you'll remember from our last video, I love to incorporate color into my notes. It kind of helps me remember things because research shows us your eye automatically goes back to a specific color. So let's go ahead and get started with these. We're going to talk about two different methods of solving when we have a linear system. Now, if you remember, a linear system is a system of two linear equations. And we're going to do the first method, which is to solve by substitution. Now, you remember, I again like to draw our attention to the fact that some of the problems in our reading guide, we have notes that let us know, hey, this one is like a particular problem on the test. I love that because I always want to make sure that I'm paying attention. The reading guide is meant to use on my test, so I want to do that. So let's talk about the substitution method. So we're going to be taking one equation and solving it for a variable. So we're going to solve equation 2 for y in this case. And I'm just going to number my equations, make it a little bit easier for us. The reason I chose to solve equation number 2 for y, you'll notice that y does not have a number in front of it. Actually, it's understood to have a 1 in front of it. So we're going to take that equation, 2x plus y equals 10, and we're going to get y by itself. To do this, we're going to subtract 2x from both sides. If you remember, I don't like to write the 2x underneath the 10 because they're not like terms. I can't actually subtract them. So I'm going to go ahead here, and then I also like to write my x's first. So I'm going to rewrite this as negative 2x plus 10. There we go. And now we're ready to substitute this into equation 2. I'm sorry, equation 1. So we solved equation 2 for one of the variables. Now we're going to go and substitute this into equation 1. So equation 1 is 3x plus 4y equals 12. And we're going to substitute negative 2x plus 10 in for y. I'm going to create space by putting the negative 2x plus 10 in for y. And you'll notice I put it in parentheses. I did this so that we distribute that 4, okay? So our next step is to solve for x. Now, if you'll notice, in addition to doing the actual work, I'm actually writing out the steps for you. This is a great tool to do when you are solving or when you're taking notes. And the reason being because you want to go back and look at your work, but you also want to know what it was you were doing in that step. So we'll be getting the 4 here. So that becomes a negative 8x. Remember, when you distribute, you multiply. 4 times 10 gives me 40. Now we'll combine like terms. 3x plus negative 8x gives me negative 5x. And then we will subtract 40 on both sides. Let's see, that gives me negative 28 equals negative 5x. And then we divide by negative 5. We're going to get that x is 5.6. Now, you may be thinking to yourself, oh, great, we've already found the answer. We found half of the answer. we actually have to substitute into one of the equations. It doesn't matter which equation. You can choose either one here. I generally choose the easiest one, so I'm going to take the 2x plus y equals 10. That's equation 2. And I'm going to put 5.6 in for x. Again, I put it in the parentheses. And let's see, 2 times 5.6 will give me 11.2. And then we can subtract 11.2 from both sides so that y equals negative 1.2. Move that so you can see that there. Now I have the full answer. I have both x and y. And so I'm going to write my answer right here in the middle here. I got x first, 5.6, and then y, negative 1.2. And like I said before, I like to incorporate color because it draws my eye to it. That's my final answer. And notice the substitution method keeps me from needing to have graph paper, which is one of the downsides of using the graphing method. So feel free to use that. I'm going to show you another method. That's the elimination method. A little bit different and a little bit we use it in a little bit different system. So remember, this system, we used substitution because we noticed that the y was by itself. In this elimination, problem number 6 here, you'll notice that all of the variables have a number in front of them. That's kind of an indication that I should use elimination. So when we use elimination, first thing we want to decide is we're going to cancel or eliminate one of the variables. It looks to me like x is going to be the easiest to eliminate. And the reason I know this is because the number in front of x is the same in both equations, except one is positive and one is negative. That's a classic case to use elimination. Because of that, I'm going to go ahead and just add these two equations together. I intentionally stacked the x's, stacked the y's, and stacked the constants by themselves. So I'm going to add these two equations together. Really nice for us. You see how the x's eliminate because 4x plus negative 4x cancels. That leaves me with 5y equals 25. You can easily divide by 5 here to get that y is 5. Now, that was pretty simple, right? It's one of the beauties of the elimination method. Now, your second step is to sub in 5 for y in one of the equations. And that step should actually sound pretty familiar from our last problem, right? That's exactly what we did at the end. We don't get out of that step in this method. We still have to do it. You can choose either equation. It doesn't matter. And so I get 4x plus 10 equals 9. Let's subtract 10 from both sides. That gives me 4x equals negative 1. And let me scoot up so you can see those steps. And so I get that x is negative 1/4, or if you want it as a decimal, that's fine as well. And we can write our final answer as an ordered pair. We've gotten 2 problems here with decimals for the answers, and you may be wondering, wow, these answers are not very nice. They're okay, all right? There's a level of coming from Algebra 1 to Algebra 2 that we look at it and we have to say, okay, now we're okay with decimals and fractions being very common in our answers. The days of x equaling 2 are kind of gone, right? That's more of like an Algebra 1 concept, or familiarity, I should say. Okay, we've got a statement here at the bottom, so let me pan out just a little bit so we can see that. When you multiply each side of the equation by the same non-zero number, the new system and the original system have the same solution. The systems are called And we could say that this means they are consistent. You can use this method to make additive inverses. Consistent there. So let me show you what that means in an example, because I think sometimes we may look at it and go, ooh, what does that mean? So let me show you. We're going to do another elimination problem. And this time it's going to require a little bit more work. I want to highlight that this problem is much like the test question number 3. So you'll want to make sure you're using that. We're going to use elimination because notice we have numbers in front of all of the variables here. So we have to decide if we're going to eliminate the x's or the y's. In this case, it really doesn't matter. You can choose one or the other. I think I'm going to do the x's just because I kind of like that. But I noticed that the numbers in front of x are not the same. So I'm going to have to be multiplying by something in order to get them to be the same. So I just do a little note taking. On my notes, I'll show you how I kind of do this. I keep the two equations stacked because I know eventually I'm going to be adding them, and that's important. I need to get a number in front here that is the same, but one has a positive and the other has a negative. So with 2 and 3, it's pretty easy that I could see where I could get 6 in front of there. Well, the way I'm going to get 6 in front is to multiply this first equation by 3. And I need to do something similar to get the second equation. I need a 6 here, but I need it to be negative 6. So I'm going to have to multiply, in this case, by negative 2. Now, when we say we multiply the equation by these numbers, we're multiplying every single term. So let's multiply. 3 times 2x gives me 6x. 7y times 3 gives me 21y. And then 4 times 3 would give me 12. Do the same with the second equation. 3x times negative 2 gives me negative 6x. 5y times negative 2 gives me negative 10y. And negative 5 times negative 2 gives me 10. Oops. All right, now let's go ahead. Now that we have those numbers the same in front of the x's, one being positive, one being negative, let's add. Notice these x's are eliminated. That's the whole purpose of what we did there. 21y plus negative 10y would give me 11y. And 12 plus 10 would give me 22. So easily I can divide by 2 there, and y would be, I could divide by 11 and y would be 2. So pretty easy once I got the same number in front of the x's to then eliminate. So my next step, my final step still hasn't changed. We're going to sub 2 for y in either equation, either one. So it doesn't really, one doesn't look any easier than the other, so I'm going to take one of the equations and I'm going to substitute in 2 for y. That'll give me 2x plus 14 equals 4. So I have 2x equals negative 10. And then so x would be negative 5. We divide by 2 on both sides there. All right, so my answer, again, as an ordered pair, would be negative 5, 2. And that finishes up our substitution and elimination method.